Hello friends. In earlier three sessions on projection of plane figures, we have discussed these cases. In the first part, we took simple cases of plane figures and also I explained alpha theta, beta phi and alpha phi cases. Means when the plane figure is inclined to horizontal plane and one edge of the plane figure is inclined to the horizontal plane, or plane figure inclined to vertical plane and one edge inclined to horizontal plane, and so on. These cases we discussed in part 1. In the second part, we discussed alpha beta case when the plane figure is inclined to both the reference planes, and also we discussed alpha beta theta and alpha beta phi case. Means when the plane figure is inclined to both reference planes and one edge is inclined to either horizontal plane or vertical plane. In part 3, we discussed theta phi and theta 1 phi 2 case. That was the case when one edge of the plane figure is inclined to reference planes, horizontal plane and vertical plane both, or one edge is inclined to horizontal plane and another edge inclined to vertical plane. Now these three parts we have discussed in earlier sessions. Today in this session we will discuss theta phi alpha and theta phi beta case. That means one edge of the plane figure is inclined to reference planes and the plate itself is inclined to either horizontal plane or vertical plane. And also I shall tell you how to determine the true shape of the plate when its projections are known, and also how to determine the inclination of the plate with reference planes from its projections. So let us first take the case theta phi alpha.
So it can be theta phi case or it can be theta phi beta case also. Now this problem is solved by taking alpha theta case first. And I explained this case in my last session. When the plate is inclined to horizontal plane at angle alpha and one edge in the plate is inclined at angle theta to the horizontal plane. So what we do in that case, because when the plate is inclined to horizontal plane, its elevation will lie on the vertical trace of the IP. So this is angle alpha, and here you take, let us say, a rectangular plate ABCD, ABCD. Say BC makes angle theta and phi. So take these two points on the vertical trace of an IP at a height difference of BC sine theta. That is the case alpha theta. You can refer that session. And this is now B and this is C dash. Rotate these points about T and hit them on the ground line. Perpendicular from these points, take B somewhere here and look at the true length of BC. Because once the elevation here is B dash C dash on the ground line, plan will measure the true length. So take the true length. True length of B you can take anywhere. If question is given, you can take. If the plan of B is given, you can take the plan, otherwise you can take anywhere. And complete the rectangle. A, B, C, D. And now you project this plate on this eye. Get the new plan. White. This is D dash, D1 dash, get a blue blank point here, and for C you get a point here. Right? So you get a parallelogram here. You get a parallelogram here. Let us say A1, sorry, B1, A1, B1 and C1. Now this is the case when plate is inclined at angle alpha with horizontal plane, one edge BC is inclined at angle theta with the horizontal plane. Now we have to add the condition of phi, that this edge BC is inclined to BP also at angle phi. And again you refer this figure when the line is inclined to vertical plane, BP dash, then this should be the line difference. That is BC sine phi. So here you see BC, that is the plan difference between B and C. But this is not BC sine phi. Okay? This is not BC sine phi. So what we do, you draw this plate again. You draw this plate again so that the plan difference between B and C is equal to, so what basically you are doing, that initially we kept the plate like this, satisfying the condition of alpha, then rotate it like this, and now you give this line, this edge, angle phi also. So either you draw a semicircle here on B1 C1 and then take the BC sine alpha as I explained earlier, or you can redraw this plate, this plan, so that the difference between B and C is equal to BC sine alpha. So what you can do, you can draw two lines here at a difference of L sine phi, and then take B here, B1 here or B here, and this distance, because this distance is not changing, plan length is not changing, so take BC here, okay, C here, and complete this figure. It's not rectangle, it's parallelogram. So you complete this figure. Like this. Let us say A and B. And now you project these points on the vertical plane. You project all these points in the vertical plane and get their elevation. Horizontal lines from each point in the elevation. This is A, this is B, this is D, and this is C. So you will get a parallelogram in the elevation also. Join them. Plate is inclined to both the planes, but you do not know the angle. Condition given is that the plate is inclined to alpha and one edge inclined to both the planes. Similarly, you can solve this case theta phi b. So in this case, you can take first as phi beta case and then add theta. Then satisfy the condition of L sin theta. Rather than satisfy the condition of L sin phi, in that case, you will satisfy the condition of elevation difference between A and B. be, when the projections are known, how to determine the true shape of the plate? Projections are known. Question is to draw the true shape of this plate. Now let us say you have a plate ABC which is inclined to both the reference planes. True shape of the plate will be reflected on a plane which is parallel to this plate. Okay? And therefore, to take this plane, what we do, first you draw a line in this plate, take the plane perpendicular to this, take a plane perpendicular to this, so that this total plate becomes a line, projection becomes a line. And then another plane which is perpendicular to this plane, or you can say parallel to HB, that will contain the true shape of the plate. So what we do, draw a line of true length in this plate, either in the vertical plane or in the horizontal plane. Let us say you draw a line AM in the plan which is parallel to ground line. Okay, so its elevation of M will be here, M dash. Now this A dash M dash is the elevation of a line which is parallel to vertical plane, which is parallel to vertical plane. Because plan is parallel to ground line. Because plan is parallel to ground line, and therefore it is parallel to vertical plane like this. So take a plane perpendicular to this line. Take a plane perpendicular to A dash M dash. Now this plane, which is now IP, this will be basically perpendicular to the plate. And therefore, if you draw its projections here, if you draw projection of this plate and measure this distance A is here, A1, B is here, B1, and C is the longest one. So you get a line C. Right? Now you take another plane which is perpendicular to this plane. Okay, perpendicular to this plane, and that plane will be parallel to the plate. So take a plane here parallel to A1, B1, C1. Parallel to A1, B1, C1. And project this plate here. Projection for A. This is the ground line now. Okay. This was the ground line XY. This is now X1, Y1, and this is X2, Y2. Remember, these two planes are perpendicular to each other. So the new ground line is X2, Y2, and old ground line is X1, Y1. So take distance of B, this one, B1 to this ground line. This distance is for B. This is point B. This distance for A, from A dash to the ground line. So A will be somewhere here. And this distance for C. This is C. This is C. So you get the plate now. ABC. And the true shape of the plate. True shape because the plan of each edge now parallel to ground line. Therefore, elevation will be true. You can draw this true shape by determining true length of each side from projections also. But that procedure becomes a lengthy procedure when you have a number of edges. For example, in case of pentagon, in case of hexagon. or in case of circular plate where there is no edge. We will discuss one more case. So if the projections are known, let me again take the case of a triangular plate, but it can be any plate. And let us say C, B and A. These are the projections of a plate ABC, which is inclined to both the reference planes. Question is to determine angle alpha beta. Angle made by the plate with the reference planes. And here you can use several methods. Method 1 would be you see, if this is the plate, what you need to draw to determine angles here, you need to draw the vertical trace and horizontal trace of the oblique plane which will contain this plate. And to draw VT and HT of that oblique plane, you determine the vertical trace, horizontal trace of this edge, and vertical trace, horizontal trace of this edge. You get 2 points on the vertical plane, you get 2 points on the horizontal plane, join them, you get VTH of the plate. So method 1 is that determine or locate HT and VT of any two edges. And I told you the method of locating HT, VT. You draw, you extend the elevation to meet the ground line, and that is the vertical trace. That is the vertical trace. Horizontal trace of AB, right? And you extend the plan to meet the ground line. That is the vertical trace. Vertical trace of AB. Similarly, you draw the HT and VT of BC, and then join these two vertical traces and two horizontal traces. You get the VTH of the oblique plane. And once you know VTH, you can determine angle alpha beta. That I explained in the session on oblique planes. Method 2 can be that if you remember when we were discussing oblique plane, I told you about this is an oblique plane, and I told you about X parallel and B parallel. If you draw a line in the oblique plane which is parallel to horizontal plane, so its elevation will be parallel to ground line and plan will be parallel to horizontal trace. Similarly, if you draw a line parallel to vertical plane, then this is called the V parallel, and here the plan will be parallel to ground line, and elevation will be parallel to vertical trace. These are called X parallel and V parallel. These are called X parallel and V parallel of the oblique plane. So if you draw any line here which is parallel to vertical parallel to ground line in the elevation, then this will be the angle of the horizontal trace, because this line is parallel to horizontal trace now. This line N is parallel to horizontal trace. So this is the angle which horizontal trace will make with the ground line. And similarly, if you draw a line here which is parallel to ground line, that is a PQ, then corresponding elevation will give you angle of the vertical trace. So you can draw now. This is the angle of horizontal trace, the angle of vertical trace you get, so you can draw VTH. And once you know VTH, you can determine the angle alpha and beta. Third method would be that if you have the projections of a plate plane where you get the edge of the plate. So take any line here, perpendicular parallel to ground line, let us say MN, and you get the plan elevation of this line. This is the M dash, and now you consider a plane perpendicular to this true length. Okay, consider the plane perpendicular to this, so that you get the plan of this ABC as a line here. That is the line. Okay, I just explained to you. That is the line. So you take this distance for A, this is for B, this is for C, and you get a line here. Let us say this is the line. A1, C1 and D. A1, C1, D1 is the edge view of the plate. Now this angle is basically alpha. That is the angle made by the plate with one of the reference plates. This angle made by this edge view with the angle made by this edge view with IP will give you angle beta. And similarly, if you obtain the edge view on ADP, then you can get angle alpha. So that is third method of finding alpha beta when projections are given. You can use any one of these three to determine the angle made by the plate. So friends, thank you very much. With that, we complete the session on plane figures. I am leaving you with 4 or 5 problems. You can try those problems, and these solution of these problems we will discuss in the next session.